Hello and welcome to the computational storage use cases. My name is Tiomkin. I'm with NGD Systems. I'm also SNIA Computational Storage SIG Chair. Today I'd like to walk you through some of the use cases, the new use cases for computational storage. And we'll start with an overview. Computational storage, taking the compute function and moving it to the storage. The main idea behind it is not to replace the host CPU or GPU, but to enhance it and provide higher system efficiency in terms of better performance and lower power, as the data now doesn't need to move once it's being processed. NGD Systems, our lineup includes today three products that are in production: the M.2 up to 8 terabyte, the 22110, the U.2 up to 32 terabytes, and the E1 short up to 12 terabytes, all with a very low power envelope. The concept of enabling computational storage on an SSDs take advantage of distributed processing. So the more CSDs you connect to the host, the better distributed processing that are available. And it adds that specific function of compute. So you have a storage device, a block storage device that can read, write, and erase. Now all of a sudden you have this fourth capability of enabling compute. And in a really high level, the programming model around that compute, which is something that NGD put a lot of effort in putting something seamless and easy to implement. So you're on the host side, you have a block device, an NVMe block device that is connected through the NVMe protocol on the PCIe bus. When you SSH from the host to the drive, you are creating a unique IP for each drive that actually creates that orange arc, which is TCP/IP tunneling. On the NGD device, there are ARM cores and an operating system. So now to enable computational storage, all you need to do is take your container, dump it in the storage, and it's running there as if it is a microserver. Or if it is an application, all you need to do is recompile it and then transfer it to the storage from the host. So let's talk a little bit about the use cases. The first one is finding a needle in a haystack, very large data set of images. And now you're trying to apply image similarity search. You upload a new image and trying to find the nearest neighbors. In a traditional compute system, every time you do that, you need to transfer the entire data set in chunks to the host CPU and memory to run this computation and reference. However, with computational storage, you can have the drives do it. And in this paper that we have published, you can look it up. You can see that the more drives you add to the system, the better the performance. And usually when you add performance, you pay a power penalty. Here it's a reverse effect. And the explanation for that is very simple. The more drives that are in the system, the more compute being done in the storage, the less data need to move from the storage to the host for reference. Moving to some of the edge use cases. So edge compute is a growing market. Gartner predicts that a third of the world data will be generated and saved and processed at the edge by 2025. And if you look at an edge compute infrastructure, so on top of the memory and CPU, if instead of regular solid state drive, you have CSDs, computational storage drives, and each one of them it can run locally, either the Microsoft Azure IoT Edge or the AWS Greengrass. You can enable the edge unit to not only get the data from the various sensors, but process it locally on the drive level, not even on the edge compute level, and move only what's important either to the cloud or back to the source. And that's been a very unique approach and a very promising one for the growing edge compute. And if we talk about edge, one of the interesting use cases that we have found on the edge is in space. So Low Earth orbit, either small sat or CubeSats that orbit the Earth, acquiring images. Today, the only option that is available is to capture the images and transmit the images. And that data movement is painful. Transmitting is require a large bandwidth. It requires a lot of data movement. And by enabling computational storage, what you can do is you can process the images or videos on board and actually provide self-autonomy capabilities to the small sat or to the CubeSat. It also improve the power efficiency of the small sat substantially, and power is very essential in space. It also increased the security of the small sat, because the less data is moving, the less chance of having that data compromised by someone that you don't want to. This is an interesting market. It's a growing market. We see a lot of players. All the cloud guys are looking into space to extend their edge and data centers. A lot of commercial and government agencies that are looking into space to acquire new capabilities. And the NGD drive has proven not only the functionality, but also some of the environmental aspect, as the extreme temperature range and even some radiation to sustain and work in that environment. The next use case is kind of interesting, and it came from nowhere. So blockchain is very hyped and in the news. Cryptocurrency. We all know Bitcoin and Dogecoin, and there are hundreds and thousands of digital currencies today in the market. And they all rely on proof of work. And proof of work was initially meant to be one CPU, one vote, but very quickly turned into the more compute power and the more GPU power you have, the better chances you have to mine the currency. And that comes with a price, and the price is energy. So we see today those mine farming companies that acquire a lot of energy. And there's a new concept in the market. It's called proof of time and space. And two good examples for that are the Burst coin and the Chia coin that are now working around that principle. And what it is instead of relying on proof of work on compute, now you rely on storage, on capacity. And the way it works, there are two different stages to enable that. So the first stage is to plot. You plot the area that is defined for the second stage, which is farming. And to do those two steps require two different skill sets from a storage perspective. From a farming perspective, you're looking for the highest capacity at the cheapest price. And for that, hard disk drives, high capacity nearline are the ideal solution. However, for the plotting, time is of essence, and there's a lot small read and write activity, and SSD is an ideal solution for plotting. And not any SSDs, but it has to be an enterprise grade SSD, because if it's a consumer grade SSD, it will burn out of write-erase cycles very quickly. So it's got to be a mature enterprise grade SSD for the plotting mission. And once the plot is done, then taking it and moving it to the cheaper large media hard disk drive. Well, when Chia cryptocurrency started trading, NGD was approached by a few players and with the questions, how can you help? Can you take that plotting scheme and add it to your computational storage capabilities? And yes, we can. So the plotting is around a core, and the more cores you have, the more plotting you can do in parallel. And if you add SSDs to that scheme, and the SSD have computational storage capabilities, now the SSD can plot in parallel to the host that is plotting. And The faster you get the plot, the faster you have the chance to farm, the faster you have the chance to actually get tokens in the actual currency, whichever it is, if it's Chia, if it's Burst, or if it's any other proof of time and space currency. So these were high-level examples of a computational storage technology enabled at the edge, in space, in the cloud, and even in a cryptocurrency solution. If you have any more questions, we'll be happy to support you, NGD Systems. And also, please take a moment and rate this session. Thank you so very much. Bye-bye.